Okay. We can start. So let's just start with number one. Yeah, this one is pretty tough because a lot of times with problems like these, I like to read them and then just from reading them, like figure out what the answer is. But
Yeah.
this one you can't really do that. It's not
Mhm.
intuitive, so we just have to kind of set it up. So we start with the base salary of X and then plus 11% of the total sales. So plus 0.11. And the total sales, that's S. That is that's our total earnings. That's like the expression for our total earnings. And then we want that to be at least three times and at most. So that's like one of these compound inequalities, basically how all the answers look. And three times and at most four times the base salary. Well, the base salary was X. So 3X and 4X. And then if
All
we,
right.
yeah,
And then just subtract 11%. I mean, wait.
well, first you'll subtract X.
Yeah.
Yeah, so it's like this is again where the two and the three come from, and it doesn't
Okay.
intuitively, it doesn't seem to make sense. But yeah, it's just
Yeah.
take X away.
And then you get B.
Yeah. So
Okay.
then you get 2X. Wait, what about this? Yep. And then divide by 0.11, and then you're done.
Okay.
Yeah, a lot of these you kind of want to go with the approach of like, I'm going to read as little as possible and still kind of like figure out the answer, but
Mhm.
which works a lot of the time, but there's exceptions to everything. This is why it's a hard problem because like intuitively the 2 divided by 0.11 doesn't seem to make a lot of sense until you just set it up algebraically.
Yeah. Okay. Thank you.
Mhm. Okay. Okay, this one is not that difficult to do. Like the actual work is not much, but it's kind of difficult to know what to do. So it wants the minimum number of trips. So before it would be worth it. So what we have to do is to find the minimum number of trips, we actually want to assume the maximum like amount for individual tickets. So what we do is we just assume that they're all cost $3.50. And I can explain that more in a second.
Oh,
So
because the more it costs, the less amount of trips you can go to like that.
exactly, yeah.
Okay.
So we don't do anything with the 150 and 250 in this problem. It's just
Mhm.
3.5x. And then we want that to cost less than purchasing, or we want the monthly pass to be less than purchasing individual tickets. So we want this to be greater than 95.
When it says like things like at least and minimum, it's greater than and at most and maximum is less than, right?
Yeah.
Okay. So
Yeah.
then, yeah.
No, go ahead.
So then is that all you do? You just divide it by 3.5?
Yeah, but then you get 27.14.
Mm-hmm.
So then the minimum number of trips will be 28 because you can't have a fraction of a trip.
But how can you go on the trip if it's if it's like a decimal
You can't.
cost?
That's why like the answer has to be 28.
Oh, I
So
get it. Okay, okay.
you're like if you only took 27 trips, 27 times 350 is 94.5. That's
Mhm.
still cheaper than the monthly pass.
Okay, understand.
But then the 28th trip is
Mhm.
now going to cost you so 28 times 3.5. The 28th trip will be $98, so then you'd be better off having the pass. So
Okay, got it.
it's the 28th trip that makes it better to have the pass. But then if if any single trip was cheaper than 350, then there would just be more trips that it would take.
Okay, I understand.
So that's why you assume the large, and then so 28 is the least, and it only happens if all your trips cost 350, but so it's not, but that's what we assume in a problem like this. So there's no way to have less than 28 trips and have
Yeah.
95 still be worth this.
Let's say it said what is the like maximum number of trips, then it would be 27. Like, I mean, sorry, you would take 1.5x and then make it great less than 95. Is it like that?
Yes.
Okay.
So the way that I did this one, I don't there might be a quicker way, but just like looking at it really quickly, I immediately think of like distance equals rate times time.
Yeah.
So for running, I had R equals 5T. And we're going to say T is the amount of time that she ran for. So then for biking, B is 10, but she biked for twice as many hours as she ran. So then the T there is really 2T. So the time that she biked is double the amount of time that she ran.
Mhm.
So rather than introduce a whole new variable, I just called this one 2T.
That makes sense.
And then running and biking is a total of 200 miles. So 5T, which is really running, and the amount of miles biked, which is in this case 20T, that equals 200.
Oh,
And it's just 25T is 200, T is 8. And then finally, the total number of miles that she biked is just putting 8 back into this equation.
okay. I think my mistake was I tried to do like R plus T is 200 and then I took 5T and like 20T, but then I thought it was going to be like a different equation. I thought it was going to be a two equation problem.
Hmm.
But I understand. Thank you.
Yeah, yeah, it's just R plus B is 200. Yeah. So then, but then you got to remember to plug it back in. So it ends up being 160. Okay. This one was probably the hardest one. So I think the way I really use the answers to help. And the first way was I thought about the units. So every problem here has 25 and 4. So 25 was miles per gallon, and the 4 was $4 per gallon. So if we were to divide those like every answer is doing, then the gallons are going to disappear.
Right.
And if we were to do the 25 over 4, we would
Mhm.
end up with miles
For dollars.
per dollar. But then M is in miles. So then we would multiply that by miles, and it wouldn't make sense. The miles wouldn't cancel out.
Oh, okay.
So it has to be $4 for 25 miles, because then when you multiply by miles, the
Yeah.
miles cancel. So that's where I got rid of these two. And then what is left after doing that? The question said to use to determine how many fewer average miles. Well, he wanted to reduce his expenditure by $5. So we needed to equal 5 because it's like he's reducing it by 5. So if we put a 5 here, then that M will give us how many miles fewer he needs. Not just like we're not looking for how many miles, we're looking for how many miles he has to like take away from what he was doing.
Mhm.
So it would make sense to use the 5 because that's what he's reducing his money by.
Okay. That makes sense. So I understand the 4 by 25. And then the 5 is because that's how much he's reducing it. So we're not looking at the amount of miles at the end, we're looking at the amount it's being reduced by.
Yeah, because of what they're looking for to determine how many fewer average miles he should drive each week. So the
Okay,
fewer
got it.
average miles should be reflected by the change in the amount of money, not like
Mhm.
the overall amount of money.
Okay, got it. Thank you.
Yeah, because I tried solving this just as if it were like open-ended, like if we had to like actually solve for M. And like, I don't know, none of these, I didn't use any of these equations. So the equation to me wasn't intuitive, which is why I was like, you know what, I'm just gonna like figure it out using the units.
Okay, got it.
All right, so the next ones. All right, so let's start with that.
I got C.
Yes,
Okay, I realized I did extra work. I should have just looked at the exponents. Cause
exactly. Yeah. Yeah, because like what they want, whoops, is they want you to, when you plug in f of one,
Mhm.
to get like whatever you get when you plug in f of one, they also want that to be a coefficient or base. So yeah, that only happens in C because when you plug in f of one, you get 128. So
Okay,
like
got it.
something like B, you would get 80 times 1.6, which is not 80 or 1.6. So they want the answer, they want f of 1 to be a number that's in the problem. And the only way for that to make sense for an exponential problem is if you make the exponent 0.
Okay, that makes sense.
So you can definitely plug it in for all of them, but yeah, the easiest way is to recognize something like this. You want the exponent to be 0.
Okay, got it. Thank you. I didn't get this one. Is it okay if you can go on, please?
Of course, yeah. This is a pretty hard one. I'll show you two ways to do it. So the more algebraic way, which could come in handy, I guess, on certain problems, is to think of this as 2 times 2 to the x. And that's because like there's an imaginary 1 here, and if I added the exponents, I would get x plus 1. And then if I factor out a 2 to the x from here, I'm left with 2 minus 1, and 2 minus 1 is 1. So what I learn is that 2 to the x is really p.
Okay.
Okay. Then if I want to get 2 to the x plus 3, that's like saying 2 to the x times 2 to the third,
Okay, that makes
which means I can just multiply each side by 2 to the third.
mhm.
So then this is 2 to the x plus 3, and this is 8p.
That makes sense. Thank you.
Yeah, I
I
would
thought
it.
that, oh, sorry.
No, go ahead.
I was just gonna say, my mistake was I did the minus 2 to the power of x, and I thought that I could move the minus to the exponent, and I did x plus 1 minus x,
Hmm.
so then I got it.
Yeah. So the reality is, I don't think I would do it this way. I do think those like concepts are important, but that's like a lot of work. Another like way that you could do this,
Yeah.
especially if you're confused with any of the algebra, is to just choose a value. So what I chose was I just made x equal to 2. I could have made it 1, but a lot of times I stay away from 1 when I'm choosing my own values. So when I plug in 2 here, I get 2 cubed minus 2 squared, which is 8 minus 4. So that
Mhm.
gives me p equal to 4.
Yeah.
And then I just plug 2 into there, and I get 2 to the fifth, which is 32. And then when I plug in 4 for every
Mhm.
answer, the only one that gives me 32 is C.
It's T. Okay, I understand.
So to me that
That's also easier.
yeah, to me that's a way quicker way. But the first way is some like algebra in it that could be useful. But yeah, when you're looking
Yeah.
at it as just like as quickly as possible, just sub in a value. And I think honestly one would work out well here too. But I just generally stay away from one, but one would have been just as easy. All right, let's try 7.
I got two.
Yeah, that's right. So what you can do, whoops, I keep doing that. So this first 5 is like 5 to the first, and this root 5 is 5 to the 1/2. And this 125 is really 5 to the third. And then this, when you add your exponents, 1 plus a half is 3/2. And then 3/2, the power to a power you multiply. So it's 3/2 n. And then this just means the exponents are equal. And then you could just multiply by 2. So you get 3n equals 6m. And then to get n over m, just divide by m and then divide by 3. So n over m is 6 over 3, which is 2.
I got A minus one.
Yeah. So basically, what I did was I took this, and that's really 2 to the second power. But then that 2 can be multiplied by this exponent. So it's really 6a minus 2. And then this is 2 to the 3 plus a times, and 32 is 2 to the fifth. And then this exponent has to equal these two exponents added together, because when you have the same base, you add your exponents. So you get 3 plus a plus 5b. And it looks like we're getting b by itself. So if I subtract a, I get 5a. If I subtract 3, I get minus 5. And then finally divide by 5, and you'll get a minus 1.
That makes sense. Thank you.
Hmm. Yeah, that's another one. If you wanted to, you could choose values, but like choose a value for one of them, and you could probably use Desmos as well. But okay,
Okay, that makes sense. I got three-fourths.
yes, yeah. This is one where I would probably just use like the Desmos calculator to help, because the one big thing is students have to remember like how to write this. So it's really 9 to the seventh over this is 9 to the 10 fourth. So it's the power over the root. We could reduce that as well, but you could kind of do this in Desmos. You could just do 7 minus 10 fourths and then divide the whole thing by this 6. So because what we're doing is we're subtracting our exponents, and then that equals this exponent over here. So then we're dividing by 6. So if you were to throw this whole thing into Desmos, you could let it do the math for you, you would get
Mhm.
3/4. But certainly you could reduce this to 5/2 and like just do the math out.
Mhm.
But this could be a quick
Would
way to like just plug it all in.
would Desmos give you the decimal version or would it give you the fraction
If you
answer?
put it in like this, it'll give you the decimal, but do you know how to click the button?
Yeah, the side button gives you. Okay, okay.
Yeah.
Okay, that makes sense. I have a question. In the SAT, let's say like I wrote like instead of writing three-fourths, I put like 6/8. Would it mark it wrong if it's not?
Yeah, the fractions are supposed to be reduced.
Okay,
But if you
got it.
put 0.75, that would be fine as well.
Okay,
Like if you did it in Desmos and didn't change it to a fraction, that would be
yeah.
fine. You just I like fractions better because like I don't know if you get like a repeating decimal or it's just or if you get like I don't know if you have like 5/7, like 5/7 would be something that you could just put in nicely, but if you actually do the decimal, then you'd be forced to round, and it's just extra thinking and an extra chance to like make a mistake.
Got it. That
But
makes sense.
there
Thank
are
you.
times in Desmos where you won't be able to do the fraction thing. Like if it's
Yeah.
like if there's like an x-intercept that's a repeating decimal and you write that, once you stop it, it's not repeating anymore. So there are, but if you're doing the calculations in Desmos, then yeah, it'll be, you can just click that button on the side and get it to be a fraction.
That makes sense. Thank you.
Mhm. All right, number 10. Yes, this is similar.
I got 7.
That is correct. So this is where like what we talked about earlier would be really easy. Um, But again, like either way, like you could make this 2 to the third times 2 to the x,
Yeah.
which is really 8 times 2 to the x minus this is kind of like 1 times 2 to the x. So it's you're subtracting, it's like terms. So you end up with 7 times 2 to the x. So then the value of k just must be 7.
Yeah, that's how I did it.
Yeah, that's probably the question. But again, if any of that is confusing to anybody, you could just like just choose a value. You could just make, let's say you did make x 2,
Yeah.
then this is 2 to the fifth, which is 32. This is 4, and then this is 2. This is 4k. And that's like, whoops, that's like super simple to solve.
Yeah. Okay. Makes
Yeah, and you also could use like do you know how to use like the Desmos regression?
if, yeah, but for this, I don't think so.
Let me just see. I'm curious myself. I'm going to see if it works. I think it does. But so you would put the left side and you would do x1 plus 3. Whoops, not like that. Yeah, I need the whole thing to be an exponent and then minus 2 to the x1 and then tilde k times 2 to the x1.
Okay.
That did not work. Oh, because I wrote x. This is 2. Yeah, and it just gave me k equals 7.
So you can put it as K as any, like you just need to make X X1 and it will take it.
Yeah, and then every x becomes x1. All the constants that are not x's, they stay the same. And then the equals becomes this like tilde symbol.
Okay, makes
And
sense.
yeah, and then what it does, it just makes it defaults x1 to be 1, and
Okay.
then it plugs that in and solves for k. So that's, but if there were more than one constant, then we could make x1, we could do like x1 equals and like we could choose multiple values.
Yeah.
But this
Okay.
one, we don't need it, but you just keep getting 7 because that's the answer. So yeah, it's definitely another one where you could um, use Desmos regression. All right.
I got 1 full.
I got something different.
Okay.
Yeah. This is a pretty tough one. So the first thing they do is they say the square of p, so p squared, is equal to the cube root of q. I'm going to write that as q to the 1/3. To me, exponents are easier to deal with. And then I want to get something equal to the square root of Q. I did this in two steps. You could get fancy and do it in one, but I'm going to do it like this. So what I did was I just cubed each side first.
Mhm.
So I got P to the sixth equals Q. And then if I then want square root of Q, I raised each side to the 1/2 power. So then I got P to the third equals Q to the 1/2.
Okay,
And
that makes
then
sense.
this 1 minus X has to equal this 3 because it says what value of
Yeah.
X would make it. So then I just say 3 equals, you can just figure out that it's X is -2. Yeah, and if you go back to the original step, if we have P squared equals Q to the 1/3,
Yeah.
if you know you want to get the square root of Q, you want this side to be 1/2. You could have just
Yeah.
in one step raised it to the 3/2.
Yeah.
Then you get P cubed equals Q to the 1/2 in one step. And then you could just figure out that X has to be -2 to
Okay.
get you this 3. All right. And I got one more.
Wait, I just redid it and I got no.
Yeah, it is 9. I did it so that might be a way. You could just do it in Desmos, but yeah, I did basically raise each of these to the fourth. Well, kind of. So you could do it that way. So I did -2 to the third to the fourth is 2 to the 12th. And
Yeah.
then 8 is really 2 to the third.
Yeah.
And then so it's like 2 to the third squared is 2 to the sixth. And then to the fourth is 2 to the 24th.
Okay.
And then you get that. And then you get 2 to the 36 is 2 to the 4n. And then you can see for these to be equal, n has to be 9.
Okay. I did it differently, but I did like kind of we were kind of saying, oh, I did -2 to the power of 3 times 2 to the power of 3 to the power of 2. So
Hmm.
that's just 3 6 exponents. So I just added
Yeah.
that. Okay.
Yeah. And it's another one that if you have trouble, like you could do just change the n to an x. And if you just put it in as is in Desmos, it'll graph the vertical line and it just graphs a
Oh,
vertical line at 9.
oh, okay. Wait, that's easy.
Yeah,
Okay.
it'd probably be easier to just use Desmos. But again, all these exponent laws are important. But yeah, that's
Mhm.
you could definitely just use Desmos on one like this as well.
Okay.
Okay, well that was the last one I had. So did you have any other questions or anything else?
But if you want, we can do that next class.
Yeah, that's fine. Yeah, just email me whatever problems and I'll put it in for next week.
Okay, thank you.
Okay. All right. See you later. Have a good night.